Hello and welcome back to another V88 YouTube video. In this session, we're going to show you how to reorder items in a list within Glide. Now, it might not sound like much, but this is not a native Glide functionality, and we have a lot of people who always ask us, and we see a lot of questions in the Glide community around this topic and how to allow somebody to change the order of items in a list on the screen within Glide. So you have a sort of table or a list or a collection, as it's called in Glide, and the question is, how do you allow the user to choose which one is at the top and to edit the order in which they appear manually? Our CTO, Mark, has put together a brilliant demonstration of this and is going to walk you through it. It's quite high level, it's quite complicated, so please do let us know what your thoughts are and if it does make sense to you. And if you guys really enjoy this one, then do reach out and we may well put together a template or something like that we can offer so that you can take this technique and use it yourselves. Hope you enjoy this one, and please do like and subscribe if you would like to see more of this type of Glide content. Thank you.
Hey everybody, welcome back. Quick little session today looking at Glide lists, but not any old Glide list. Today we're going to do lists where you can change the order of the items in the list. Something we've been using in projects at V88 now for quite a while. But I know there are some of you out there who perhaps are still a bit confused as to how this technique works. It is a little bit funny. So I'm going to show you today how we do this sort of thing. We have a list here and how we can move the final step up or back down again. We can move any list item anywhere we want to move it. Okay, so how do we do it? Well, first of all, let's just explain the setup that I've got here in this little demo app. So I've got myself 3 projects, and as per usual, we'll have a quick look at the data. That's where it all begins. Here's our projects. We've got a row ID, they've got a name. Okay, and then for this demo, our projects have got steps. And those were the things that I was moving up and down here. These are the steps in project A. And the steps for all projects are held in a project steps table, like this. And what you will see is over here, we have the project ID. So this tells us what project the step belongs to. All straightforward Glide stuff so far. So therefore, looking back in the projects table, not surprisingly, we've got a relation which is a relation where the project row ID matches steps in the project steps table, ID, match multiple, and that pulls back all the steps for the project. We've also got a count here. It's just a simple roll up that tells us the number of steps for the project. And over here, we've got a next logical index, which is basically if you were going to add a step, what position would it be in? Okay, let's have a look at the steps table. So the steps all have an index, and that is the position that they are in within their respective project. Okay, so just jumping into the UI at the moment, the steps here, that collection, is sorted by index. And that's really the key to this, because if we sort by index, then all we need to do behind the scenes is manipulate an item's index, and Glide will handle the rest by simply putting it in the right position. So this item here will have an index 4, it's the 4th item. So if I could change its index to 3, then no surprise, it goes up 1. But of course, what we've also got to do is change this one's index, which was number 3. We have to change that index to 4. And that's just where it gets a little bit quirky. But let me show you how that works now. So the key to this is mostly in the project steps table, your child table. Okay, so the first thing we have here, as I said a moment ago, is the current index. So that is the position of the child. In this case, it's the position of the step within the project. Then we have a relation to all of this step's siblings. So By siblings, in this scenario, I mean steps that are in the same project. So that relation simply says, relate to the items where the project ID matches the value in this same table, project ID. Lo and behold, what I now get is a list of all the siblings, so all the steps in the project. So just to clarify that, in case it's not obvious, if I come back here and go into project B, which has no steps, and I'll add one. First step in project B, poor spelling as per usual. Okay, if we look back into the steps table, you'll see now that that one has only got one sibling itself. There is only one step in that project. Okay, so it's just important to remember what you're creating with that relation. It's the siblings. Okay, so the next thing we can now do is, again, all under siblings, we can come here and calculate the minimum index. So all that this does is has a quick look over the siblings relation and it finds the minimum index. Similarly, we can find the maximum index here. Now, not surprisingly, the minimum is pretty much always going to be 1, and the maximum is going to be the count, the number of siblings. But I choose to use min and max, and the reason for that is that we're currently working on a version 2 of this particular algorithm, which we'll show you someday. And in that version, the minimum may not be 1. But to get this working and to get it working very nicely, we will assume that the minimum is always going to be 1 and the maximum is going to be the count. Okay, so the next thing we need is we need to understand a little bit about this item's previous item, if indeed there is one. And that's pretty straightforward to find out. The first thing we can do is work out what the previous index would be. So looking at the first item as our example, its index is 3. So the index of the previous item will be 2. No surprise, that's just the maths column. This index minus 1. Okay, so what we can now do is we can now query our siblings to find the one that has an index matching previous index. So this is just a query that looks through all the siblings and it looks where the index equals this row's siblings previous index. Okay. So the one little shame here is we now need to turn that query into a single row. And the best way to do that is simply use, not surprisingly, a single value. So if we look at this query, we've limited it to return 1 only, and there will only be one match. And so what we can do here now is have the previous relation, which is a single value, and we simply take the first from this query, which will actually be the only one, but it gives us a nice full row to play with. So just to recap on that, these 3 columns here are used to give me a relation to the previous step in this group of siblings. Interestingly, of course, if we look down at this step that we added in project B here, there is no previous step, and therefore the previous relation is empty. Okay, now we do exactly the same thing, but kind of converse logic, to give us the next step in our group of siblings. So we create a next index. This time it's simply this index plus 1. Then we do a query to find it, and then we use a single value to pull it out as a relation. So now we've got the previous relation to this particular step, and we've got the next relation to this particular step. Now again, if we were to look at this step here, whose index is 1, not surprisingly, we don't have the previous relation, we only have a next one. And if we were to look at this step here, with index 4, we know there are 4 items in total, so whilst it's got a previous, it won't have a next. Okay, so hopefully you can now see how it's fairly straightforward for a given item here to get a relation to the previous one in its group of siblings and to the next one in its group of siblings. Okay, how does that help us? Well, it turns out it helps us a great deal, but there's one other thing we need, and that is we need somewhere to store a temporary index. because we're going to be jiggling these indexes around a little bit, and we're going to need a little store place. So I've got this helper here. It's called temp index. I've made it user specific so that we don't have issues with multiple users moving things around at the same time, just in case. Okay, so how do they all hang together? Well, let's have a quick look. Let's go back into our UI and look at project A. And if we look at the collection here, we look at the actions, you can see we've got a move up action and a move down action. We've also got a delete one. I'm going to talk about that a little bit later. So we've got a move up and a move down. Let's go and have a look at move up, see what it does. Okay, so this is one of the new little features of Glide that's just crept in, the ability to rename your action steps or stages. Really, really nice, because now the action pretty much tells us what it does. So if you imagine what I want to do here, if I'm moving something up, I want to swap it with the item above. Okay, so it's the question of basically exchanging index numbers. If I swap the index number of this item with this item, they're going to go like that. Nice and straightforward. But we need a temporary area to store the index that we're changing. So if you look at this, all we do here, let's read it in English first. We store the previous item's index in a temporary location. So we've got a hold of the previous item's index. Then we set the previous item's index to this item's index. And then we set this item's index to the one that we stored from up here. As simple as that. And what that will do, using that temporary storage, will simply swap the indexes around. If you actually look at it in Glide speak, storing the previous item's index in temp, so here, set column values, into temp, siblings, previous index. Then we set the previous item's index to our index. Look at that in Glide speak. So what we're doing here is setting the column values, not in our row, but in the siblings previous relation. We're setting that to index, our index. And then finally, back in our row again, we set our index to the value we stored in temp, which was, from step 1, the previous item's index. So we swap them around. Simple as that. What we can also do is if we look at move down, it does precisely the opposite. But it works with the next item. So we store the next item's index in temp, we set the next item's index to our index, and then we set our index to the one that we stored in temp. So what this does is swaps us here with the one after us, therefore moving us down in the list. And the end result is this. Okay, so a little bit of logic to also think about. What we don't want to do is move the first one up or the last one down. And you'll see you actually can't. And the way we handle that is in the action again, in the move down action, we say, well, we're only going to do it if the index, if the index is less than the max index. Okay, we can't move down if the index is not less than the max index. So put that in there, the action won't trigger in that scenario, and Glide rather nicely will hide the arrow for us. Perfect. And similarly in move up, we only want to do that if the index is greater than the minimum index. If it's not, then there's nothing to move up to. So again, we rely on Glide to switch off the UI when that action can't be run. So really nice and simple. There we have it. Now, 2 points to consider with this particular technique, which is why I alluded to a potential version 2 that we're working on. So the first thing is when we add a new step, we need to add it at the end. So you'll notice if I add something here, it's going to go at the end. Okay, and how do we do that? So simply in the add form where we're setting up the project ID that this step belongs to, we also pull in here from the screen, we pull the next logical index and we stick that into the index number. And the next logical index over here is simply the current count plus 1. So that's easy enough. It's somewhat annoying that everything goes at the bottom and then you have to move it where you want to move it to. But actually, in real world testing, in most of our projects, we find that our clients, when they're adding stuff, it is going on to the bottom of the list, and then they may jiggle it around to put it where they want to. So it's not such an issue. Now let's look at deleting. So I have got myself a delete action here already. I wanted to hide it. I've got myself a delete action here already, and I wanted to hide it. So I just set email is empty here. But actually, what we have to do there is come in here and delete this item, but only if it's the last one. So basically, siblings next query must be empty. So we can only do a delete on the last item. What does that look like now? So now you'll see delete has become available here. And the reason for that is because in this version of the algorithm, we need to ensure that our indexes follow on sequentially. So if there are 5 items, the algorithm relies on the fact that they will always be numbered 1, 2, 3, 4, and 5. And so if we go delete one in the middle, we've got ourselves a problem, we've got a hole. Okay, so if you want to delete a particular item, you need to move it down to the bottom, whereupon it can be deleted. So there we go. Hopefully that's a reasonable overview of how you can create dynamic lists that you can allow your users to move around from the UI. They work nice and quickly. They're all in Glide, so we've got no JavaScript or anything like that in this particular version, which is always nice, I think. A couple of little iffies. You can only add to the bottom, you can only delete from the bottom. But watch this space, because we've got a few ideas as to how we can make this algorithm even better. So I hope it's been useful. Go build some lists. Let's see what you build. Thank you.